Hello, good morning, boys and girls. We are on page 18, lesson 4. Make sure you are on the correct page. For problem number 1, they ask you to do the following problems. Draw a picture using a rectangular fraction model and write the answer. When possible, write your answer as a mixed number. So, first thing I'm going to do is I am not going to be using the rectangular fraction model, but I will be using the standard algorithm. So I am going to be adding 3/4 plus 1/3. I am finding the multiple for 4 and for 3. Why am I finding the multiple for 4 and for 3? Because I want to make sure that I am writing my multiples 4 and 3 to be added together, but they need to have the same common denominator in order to add together. Just like I told you before, you can't add oranges and apples together because they're not going to give you apples. And when you add oranges and apples, you're not going to get oranges either. So you need to make sure that you're changing them in order for it to be the same. So my multiples for 4, 8, 12, 16, just like skip counting. And my multiples for 3 are 3, 6, 9, 12, 15. So I'm looking at my numbers here and I notice that 12 and 12 both appear in my 4 and 3s. So that means that I'm going to try to make sure my common denominator changes into a 12. So now I'm going to multiply. 4 times what is going to give you 12? 4 times 3 is going to give me 12. What I do to the bottom, I must do to the top. On the other side, 3 times what is going to give me 12? 3 times 4 is going to give me 12. Now look, my common denominators are the same. 3 times 3 is equal to 9, and 1 times 4 is equal to 4. Now I'm going to add everything together. 9 plus 4 is equal to 13, and 12, you bring it right over. You do not add those numbers together, you leave them alone and bring it right over. Okay, so we get 13/12. If you want to change it into an improper fraction, which is something we will be learning soon, you can change it into an improper fraction. You would get 1 and 1/12 as your improper fraction because 12 goes into 13 one time and we have a remainder of 1/12. Now on this side, I have 3/4 plus 2/3. I'm going to change my denominator into a denominator that can be the same. So for 4, I'm skip counting 4, 8, 12, 16. For 3, I'm skip counting 3, 6, 9, 12, 15. And I notice that the lowest common denominator is 12. So I'm going to make sure I multiply my bottom number to get 12. So 4 times what is equal to 12? 4 times 3 is equal to 12. 3 times what is equal to 12? 3 times 4 is equal to 12. And what I do on the bottom, I must do on the top. So 3 times 3 is equal to 9, and 2 times 4 is equal to 8. 9 plus 8 is equal to 17, and 12 plus 12, or 12, you just bring it right over. So my final answer is 17/12, or it would be 1 and 5/12 if I were to change it into an improper fraction. Because 12 can go into 17 one time, and we have 5 left over as a remainder, so we have 5/12. Now for problem C, I have 1/3 plus 3/5. I know that I need to change my common denominator to something that is the same for both 3 and 5. For 3, I'm skip counting 3, 6, 9, 12, 15, 18. For 5, I'm skip counting 5, 10, 15, 20. So I notice that 15 is my common denominator. So I'm going to multiply my bottom number, the denominator, to get the same common denominator for both ones. So 3 times what is equal to 15? 3 times 5 is equal to 15. And 5 times what is equal to 15? 5 times 3 is equal to 15. And what I do on the bottom, I must do on the top. So 5 times 1 is equal to 5, and 3 times 3 is equal to 9. I'm going to make sure I add everything together. 5 plus 9 is equal to 14, and 15, I bring it right over. So I have 14/15 as my final answer. Now for problem D, I have 5 6 plus 1 12. For 6, I'm making sure that I do my multiples. So I have 6, 12, 18, 24, 30. I'm skip counting. And for 2, I'm skip counting 2, 4, 6, 8, 10, 12. I notice that the lowest common denominator is 6. Notice there is a 12. They both have 12. I could use that. But why would I use a bigger number when I can use a smaller number and work with smaller numbers to multiply? So I'm going to use a smaller number. So 6 times what is equal to 12? 6 times 2 is equal to 12. And 2 times, oh, what did I do wrong here? So 6 is the common denominator. So that means that I don't have to multiply this times 2. I don't know why I did that. Silly me. So this one I could leave alone as 5, 6. So this one I can leave alone as 5, 6. I don't have to multiply the top or bottom, so I'm going to leave it alone. And on this side, I'm multiplying times 3 because I want 6. 2 times 3 is equal to 6 for my denominator, and 1 times 3 is equal to 3. 5 plus 3 is equal to 8, and 6 is my denominator. So my final answer is 8, 6, or you can get your least common, your improper fraction is also 1 and 2, 6, or 1 and 1/3. And how do I know that? Because I simplified it to the smallest number. What I did here was I divided the top and bottom number by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. And 6 can go into 8 one time. The remainder would be 2, and my bottom number is 6. Now I am going to turn the page. I am working on problem E. For problem E, it says here that I have 2/3 plus 5, 6. I'm finding the common multiples of 3 and 6. I'm skip counting 3, 6, 9, 12. I'm skip counting 6, 12, 18. So here I have 6, and here I also have 6. Okay, so what I'm going to do now is I am going to multiply. So I want to make sure that my least common denominator is going to be on the bottom. So 2 times 3 is equal to 6. And 2 times 4 is equal to 4. I'm going to add 4, 6 plus 5, 6. 4 plus 5 is equal to 9, and my common denominator for the bottom is equal to 6. So in order to get the same, in order to change it into a mixed number, I need to figure out how many times can 6 go into 9? One time. And I have 3, 6 as my fraction, but I can still divide this by 2 over 2. Sorry, not by 2 over 2, by 3 over 3. So 3 divided by 3 is equal to 1, and 6 divided by 3 is equal to 2. So I get 1 and 1/2 as my final answer. Now I'm going to work on problem F. We have 4/3 plus 4 7ths. I'm skip counting for 3. 3, 6, 9, 12, 15, 18, 21. For 7, 7, 14, 21, 28. Notice that 21 is the least common multiple. So I'm going to be multiplying bottom number times 7 times 7. 7 times 4 is equal to 28. 7 times 3 is 21. 4 times 3 is 12. And 7 times 3 is 21. I know that 21 and 21 for my denominator stays the same, and I'm going to add 28 plus 12. 8 plus 2 is equal to 10. 2 plus 1 plus 1 is equal to 4. So I have 40 of 21s. So how many times can 21 go into 40? One time. What would my remainder be if I were to subtract 40 minus 21? I would get 19. So I have 19 21s. So this would be my improper fraction. And this one would be this would be my mixed number, and this is my improper fraction. So both answers are correct, but sometimes you might see this one, your improper fraction. So that's why I'm showing you both. For problem number 2, it says here, solve the following problems, draw a picture, and write the number sentence that proves the answer. Simplify your answer if possible. Sam made 2/3 liters of punch and 3/4 liters of tea to take to a party. How many liters of beverages did Sam bring to the party? So I'm going to skip count. I'm adding these two numbers together, 2/3 plus 3/4, in order to figure out how much did he bring to the party. So for 3, I have 3, 6, 9, 12, 15. For 4, I have 4, 8, 12, 16. So it looks like 12 is my least or my least common multiple. So I'm multiplying to get 12. 4 times 3 is equal to 12, and 4 times 3 again is equal to 12. What I do to the bottom, I must do to the top. 2 times 4 is equal to 8, and 3 times 3 is equal to 9. 8 plus 9 is equal to 17. Bring my 12. My final answer is 17 twelfths, but you can also find the improper fraction by writing 1 and 5 twelfths. How did I figure that out? I divide. So remember I told you this bar right here is a fraction bar. It means 17 divided by 12. So I'm writing here 17 divided by 12. 12 can go to 17 one time. Subtract. 7 minus 2 is equal to 5. My remainder is a 5, and my denominator is going to stay as a 12. That's how I'm getting my mixed number. So Sam bought 1 and 5 12 liters of beverages to the party. Now for problem number 3. Mr. Sinofsky used 5/8 of a tank of gas on a trip to visit relatives for the weekend and another 1/2 of a tank commuting to work the next week. He then took another weekend trip and used 1/4 tank of gas. So the first thing I'm going to do is I'm going to find the common denominator for 1/2 plus 1/4 because I need to figure out how much is he using altogether. So looking at my multiples, I have 4. So I'm going to make sure that I multiply times 2 in order to get 4. 2 times 2 is 4, and 2 times 1 is 2. I'm going to add 1/4. 2 plus 1 is 3. Bring my 4 over, and I get 3/4. Now, for this one, I'm going to add 3/4 plus 5/8. Where am I getting 5/8? Right here in the word problem. I am looking for my multiples of 8 and 4. 8, 16, 24, 32, 4, 8, 12, 16. So it looks like 8 is going to be my common multiple. I multiply times 2. 5/8 plus 6/8. I know that 5 plus 6 is equal to 11, and 8. I bring it right over is 11/8. If I were to change this into a mixed number, I would divide 11 divided by 8. 8 can go into 11 one time. 11 minus 8 is equal to 3. So bring my 3 right here, and my denominator is going to be 8. So I get 1 and 3/8 as my final answer. Okay, so Mr. Sinofsky used 1 and 3/8 tanks of gas.